Okay, so here's an example of a KMap, and this says f function of ABC is a sum of minterms 0, 1, 4, and 5. So another way we can write this is to say function of A, B, C is equal to, we take the 0 and we write the ABC version of that, right? We convert that to ABC. So 0 is actually 0, 0, 0. 1 is 0, 0, 1. 4 is 1, 0, 0. And 5 is 1, 0, 1, right? So 0, 0, 0, and since we're doing a sum of minterms, the 0 will be a bar and the 1 will be the variable itself. So that would mean for each term I would write ABC and then put an OR, ABC and then put an OR, ABC and then put an OR, ABC and then put an without an OR at the end because we only have 4 terms. Then I look at the number that I have. For 0, they're all zeros, right? For number 0, I have all zeros, so I put bar, bar, bar to represent all zeros. And for some reason, the bar is not transferring up there. There it is, it's showed now. Now for the next one, I have A001, so I'm going to put a bar, and then I'm going to leave C on its own as a variable without a bar on top of it. Now for the third term, A is a 1, and then BC will be 0, so I'm going to put 2 bars on top of those numbers. And then for the last term, I have 101, so I only need a bar on the B. Make sense? So now what I'm going to do is I want to convert that into a KMap. Okay? So now that I know I have 4 terms, each one of those terms, those minterms will be placed as a 1 inside my KMap. How many variables do I have in my function? This function is a 3 variable function. So I'm going to have to draw a 3 variable function. Well, like I showed last time, it would be easier if I draw a cell map first. So I'm going to go ahead and draw a cell map. And that cell map is ABC. And I put 0, 0, 0, 1, 1, 1, 1, 0. And then the C is 0, 1 on the end. Now because of that, if I go on the top, I see AB is 0, 0, and on the side C is 0, so that is cell 0. And then on the top is 0, 0, and then on the side C is 1, so this becomes cell 1. So that's minterm 1. And then I go on the top in the second column, the top is 0, 1, and C on the side is 0, so that is 0, 1, 0, so that is cell 2. Right? And then top is 0, 1, side is 1, so this is cell 3. I skip a column, go to the top right corner, 1, 0, 0, AB is 1, 0, C is 0, so that's cell 4. And then below it is cell 5. And then this is cell 6, and this is cell 7. So now I've identified all my minterm cells. Now that I know all my minterm cells, I can draw my KMap. Now, of course, initially you draw those cells because you want to know how to fill in your KMap. Once you get accustomed to this, you don't have to draw these cell maps anymore. Now, you're supposed to, if you look back up here, you're supposed to fill in cell 0, cell 1, cell 4, and cell 5 with 1s because this is a minterm expression, right? So you want to fill in cell 0, cell 1, cell 4, and cell 5 with 1s, and everything else gets filled in with 0s. And that's how you fill in your KMap. Now if you fill in the 1s and don't fill in the 0s, you have an incomplete KMap. You haven't done your job. Okay? Now that I've done this, now I have to group the 1s. Okay? And I'm sorry it's flickering. It's flickering because of the internet, I guess. So now I have to group the 1s. Now I could group the 2 on the right on their own, and I could group the 2 on the left on their own. So here's what I could do. I could say I'm going to group these 2, and I'm going to group these 2. Agreed? If I group these 2, this would give me, how do I group? I said when I group numbers together, I group in groups of powers of 2. 1, 2, 4, 8, 16, 32, powers of 2. So I group the 2 together. I go up and look at A. A for the 2 cells within that group, A for the 2 cells within that group is not changing, and it's constant at 1, so I keep A. I look at B. B for the 2 cells in that group is constant at 0, so I keep B at 0. And then I go to the side and I look at C, and C is changing. It goes between the 2 cells in that group, it goes from 0 to 1. So I discard C. So I discard C. So that becomes my term for that group. Then I look at this. A is constant at 0 for both cells in that group. B is constant at 0 for both cells in that group. And again, I discard C. So what this is telling me is F is equal to A bar B bar or A B bar, right? But then the problem I'm seeing is, if I did some Boolean algebra on this, I could take B bar common factor, and I get A bar or A, which is equal to 1, which ends me with B bar, right? Which means something went wrong in what I did up there. I didn't group the biggest group of 1s I could have. So I'm going to redraw this because I clearly didn't do it correctly. So I'm going to redraw this, and did a horrible map right there. ABC 0, 0, 0, 1, 1, 1, 1, 0. I'm going to redraw my 1s. And I'm going to look at this again, and if I take my map and I fold my map to the side where my 2 edges, if I roll it to a cylinder, where my 2 edge 1s, the ones on the edges, touch each other, I could in essence group these 4 together, just like I showed you in the examples. So I can roll this map and I can touch those together. And if I touch them together, those sides touch, so I can group them. Now if I group them, now I have to see what is common between those 4 cells. I go up to the top and I look at A between these 2 cells and these 2 cells. So between the 4 cells, is A constant or is it changing? So for the first two cells, A is 0. For the second two cells, A is a 1. So A is changing between the 4 cells, discard. Then I look at B. B is constant at 0 for the first two cells. B is constant at 0 for the second two cells. So B is constant at 0. Keep. Now looking at C across the two rows, because I have 2 1s on the first row, 2 1s on the second row. So C is actually changing across the 4 rows. So C is changing across the 4 cells. So you discard. So therefore this is only B bar. So therefore F of A, B, C is equal to B bar. So you see over here, I got it in one step, which is what I should when I have a KMap, whereas up the previous example, I did it incorrectly. I grouped 2 groups instead of 1, which meant I had to do some Boolean algebra to get the right answer in the end. Alright, so again we follow, this example is asking us to group the ones. Okay, so we're going to look at the first KMap, and remember what I taught you is to first look at, if you have a single one that has no other one that you can group with it, only a single one that there's no other one that's logically or physically adjacent to it, you group that first. Then you look at the ones that are the maximum number of ones you can group together, and then you group those together. So that's what we're going to do. So does anyone see a single one up here that's on its own? Because I can see one. There's a single one that's on its own up there, that if you roll the map sideways, like roll it cylinder from the short ends or cylinder from the long ends, it will be on its own. There is nothing else that you can group with it. It is this cell right here. There is nothing around it that I can group it with, clearly. If I roll my map from the short end, if I roll it from the long end, there is no other one around it that I can group it with. So that becomes a minterm. So I'm going to say F of A, B, C is equal to that minterm. And since it's that minterm, then that term is going to have all my variables in it. So it is cell 0, 0, 0, so it's going to be A bar, B bar, C bar. And I'm going to put an OR. Now I'm going to look at the other groups. And then based on the other groups, I'm going to see there's other ones. And I see there's 4 more ones in there. And I have to make these groups. And it looks like, from what I'm seeing, I'm going to have to make 3 groups. I'm going to have to group this one on the edge with the center one. I'm going to have to group the one on the top also with the center one. And I'm going to have to regroup that center one with the one on the other edge, because the more the merrier. I have to make sure that I take those ones that I haven't taken into groups of 2, rather than take them on their own after I've taken that bottom center one, that cell number 7. Because I can retake a 1 in as many groups as I want, as long as that new group has a new 1 in it that has never been taken before, which in this case I do. Every time I've regrouped cell 7, it's been regrouped in a group where there was a new 1 that's never been taken before. So now I'm going to look at the group that combines cell 5 and cell 7 together. So I'm going to look at this group. So that group, I will go up. A is not changing, and it's constant at 1, so I'm going to put A. B is changing, so I'm going to throw it out. C is constant at 1, so I'm going to keep it. So this group right here, you go up, A is not changing, so it's constant at 1. B is not changing, it's constant at 1. But the group is across 2 rows, so C is changing, I throw it out. Now for this group, A is changing, so I throw it out. B is constant at 1, so it's B. C is constant at 1, so it's C. And there's my final equation. And if I look at that equation, there's no way I can minimize it further. Now if I look at my second K-map, for this K-map, there's no single one on its own that I can group, so I can't do that. So then I look at what is the maximum number of ones I can group together, and I see that I have these 4 that I can group together. So I group them. And then I see that I can group these 2 together. So when you group the group of 4, you go up, A doesn't change. So it is A. Oops, let me do it small. And then B changes from 1 to 0, so you throw it out. C changes from 0 to 1, so you throw it out. Now we go to the center group. That is similar to what we had before on the previous K-map. So it is B and C, same as before. Now if we go to the 4 variable K-map, that's a little bit different, right? For the 4 variable K-map, we have this guy over here that's on his own, right? There's no one else with him, so we're going to take that one on his own. So this is going to be a function of A, B, C, and D. And that one, A, B, C, D, is going to be 1, 1, 0, 0, because it's just a minterm. Right? Now I want to start grouping my ones. Now the next step I will do is there's a lot of ones on the right, a lot of ones on the left. I'm going to look at that one in the center in the second column and say, well, the only way I can take that one is with the one next to it. You see how I start eliminating? I start clearing off those ones by looking at what's the easier one to group, that there's no other way to group it than this, to make sure that I'm not going to start taking redundant terms without realizing. Okay, make sense? So I'm going to group those 2 together. So because when you go up, A is a 0, so A is constant at 0, so I keep it at A bar. B is changing, so I throw it out. Then I go to the side, and C is constant at 0, so I keep it at C bar. And D is constant at 1, so I keep it at D. So that would be my term. And then I look for my next group. Now I have these 6 ones on the side. 5 of them haven't been taken yet. I can only group in groups of 1, 2, 4, 8, 16, and so on. Groups of powers of 2. So I know I can't group groups of 3 or groups of 6 or groups of 5. I can't do that. Those are not allowed. So I can definitely group these 4 together, because what did I say before? The more, the merrier. So I can group these 4 together. So now I'll go to the top and I'll look at A, and A is changing, so I throw it out. Then I'll look at B. B is constant at 0, so I'll keep it. Then I'll go to the side and look at C. C is constant at 1, I'll keep it. And D is changing, so I'll throw it out. Now, what I'll do is I have this lonely one right here that I have to group, but I don't have to group it on its own. I can take this one with these 2 and these 2. And I'll do the same thing. I'll look at those 2 and I'll go up. A is changing, I throw it out. B is constant at 0, so I'll keep B at a B bar. And then I'll go to the side, and C now is changing, so I throw it out, and D is constant at 1, so I'll keep D. And there's my equation. Now let me show you drawing the K-map and how I draw it quickly. There. Let me draw the ones and the zeros in there for you. There's my ones and zeros, okay? So, let's figure out how to group this. So one thing you might want to do in this one is say, well, I have this column right here. I'd like to group all these 4 ones in one column, right? I wouldn't advise that, because if I group that whole column, I might make a mistake on having a redundant term, and I'll show you why in a minute. So I'm going to first take these 4 together, and I'm going to say function of A, B, C, D. This is F. This is F. This is F. Function of A, B, C, D is equal to, and I'm going to take these 4 together, and I'm going to go up again. A is changing, I'm going to throw it out. B is constant at 0, so I'm going to take B. C is constant at 1, so I'm going to take C, and D is changing, so I'm going to throw it out. Okay? Now, then I'm going to say, well, I can take these 4 together as a group. And if I take these 4 together as a group, I go up. A is constant at 1, so I'm going to keep it. B is changing, I'm going to throw it out. C is constant at 0, so I'm going to keep it. D is changing, so I'm going to throw it out. Then I'm going to look, and I'm going to say, well, then I want to take these 2 together. So I'm going to look at these 2, and I'm going to say, if I go up, A is changing, I'm going to throw it out. B is constant at 1, so I'm going to keep it. To the side, C is constant at 0, and D is constant at 1. And then, what do I do with that last one? So if I roll the map, cylinder method, if I roll the map left and right, left to right, then I can group the 4 corners, which means I go left column, right column, go to the top. A is changing, I throw it out. B is constant at 0. Oops. B is constant at 0, so I keep it, B bar. And then first row, last row. C is changing, I throw it out. D is constant at 0, and I keep it. And that finishes that problem.